Okay. Hello. Can everyone hear me? Hi. Good afternoon. Thank you for coming. My name is Alessandro Segala. I work for Microsoft during my full-time job, but I also enjoy hacking with some really cool stuff. And today, I'm here to talk to you about the Inter-Planetary File System, or IPFS. This is a talk about the distributed web, but I promise there will not be any blockchain in this talk. So before we start, can I see a quick raise of hands who has heard or used the IPFS before? So it seems like this is a new topic for most people. So let's see how we can learn about this. So what is IPFS? So the definition that you see here, this is actually my definition. It's not exactly their own, but I describe it as a distributed peer-to-peer protocol and network for accessing documents. There's a few things here, but you can think about IPFS as a sort of decentralized replicated peer-to-peer CDN. The concept of peer-to-peer is in opposition of the traditional client-server method. As you can see here, this is the full extent of my Illustrator skills. But in a traditional model, like most of us have been building apps forever, there is a centralized server or a cluster of servers, and all the clients connect to that server. And the servers serve the content, do all the processing, etc. In a peer-to-peer model, which is something that you might have heard before if you have used things like BitTorrent, which I've absolutely never heard. But every node in the network has the same documents, and every single node that is trying to access a document can request it from every other node in the network. So it's essentially think of you acting as a client, but also as a server at the same time. Keep in mind that peer-to-peer does not mean serverless. In fact, as you can see here in this graphic, there is a server in here. This is because nodes, clients, can come and go, can join the network, and disappear at any time. They might or might not have the documents you're trying to share. And so it's important to keep one server up and running 24/7 as a seeder for your files that are in the peer-to-peer network. One particular characteristic of IPFS is that every time a node accesses a file, it also starts seeding it. So this means that the more popular a file is, the more people request that file, the more spread out throughout the network is, and the more available it is, which also means that it becomes faster, and that it's really, really, really hard to do a DDoS on IPFS, because as people try to attack the network, they request the files, and they actually start seeding it too. So it's literally the opposite of what people are trying to do. Before we get into the next part, one important thing that I want to point out is that IPFS, when you think of this, you hear the name file system. A lot of people think that it's a sort of NAS. It's not. I actually think that is the bad stuff about the name. But IPFS is not a NAS. You don't just upload your files into this network, and then the network keeps your files forever. It's more of a CDN, literally. You just use IPFS to distribute your content, but you must always keep one node up with your data 24/7 if you want to make sure that there's always at least someone seeding your files. I'm going to go in a demo in just a moment, but before we get into that, there's another concept that I need to explain, which is the content IDs. So inside the IPFS network, files are addressed using their content ID. It starts with /IPFS/something. That something is, simplifying a little bit, it's a sort of the SHA-256 hash of the file. And so each file in the network is addressed by its own hash. I can also request a folder. In this case, as you can see in the second example down there, in this case, I'm requesting the README file inside a folder, and that is the hash of the folder. The hash of the folder is calculated from the hash of every single file. It's not exactly the SHA-256. It's a little bit more complex than that, but we don't have a lot of time today to get into the actual details of the network. But these two addresses above, they actually point to the very same file. So if you request the first one, you're going to get the README file by requesting the file directly. If you request the second one, you're going to get the README file by requesting the file inside the folder. The biggest benefit of addressing content by its hash is that the network is tamper-proof. So if one of the nodes in this peer-to-peer network were to send tampered content, like maybe a malicious actor that wants to do a man in the middle and serve you modified content, then the client would be immediately able to understand that the file was tampered with and would reject that block. The other benefit of addressing content via the content IDs or the hash but which is also a challenge, is that the content is immutable. So if you change, as you know, if you change even a single bit in a file, the SHA-256 hash of the file is completely different. So we will need to look into ways that we can make it possible to actually update a content that doesn't require changing its hash. Let's get into the demo right away, and let's see how IPFS works. So I have my machine here, and I have IPFS installed. And I can show that it's installed by running IPFS version. And the very first thing I want to do is running an IPFS node inside my machine. So I'm starting it with IPFS daemon. This should take just a second, and it will start. Now it's ready. Let's open another terminal, and let's request a file from the network. Most commands in IPFS are inspired by the standard Unix commands. So in order to request a file, for example, the command is IPFS cat, and then the address of the file. So let's request that README file I was talking about a moment ago. And you can see that the file is loaded. So this is me requested a README, and I requested it through the peer-to-peer network. And some people somewhere in the world sent this file to me. I can also list the content of a folder. So this file is inside a folder. And again, the command is IPFS ls. S4. And you can see that this is a folder. It contains a bunch of different files. Each file also has the hash of the individual file. Of course, I can request a file inside the folder. So let's do IPFS cat. Inside the folder, I want the README file. And you can see it's exactly the same file. But this time, I access it through the folder rather than the file itself. We can publish documents on IPFS. So I have a folder on my desktop called Good Boys. You can probably imagine what's in here. And there's a bunch of files. So let's add IPFS add one of these files to the network with the IPFS add command. You can see that my machine hashed the file and then published it in the IPFS network. So now everyone in the world with this address can retrieve this file from my machine. I can also publish entire folders with IPFS add -r for recursive and the folder name. And now I'm publishing the entire folder. So this is how you retrieve and add files from the IPFS network. Some of these things that I published are documents, like images, that do not really work well inside a terminal. I don't think you can really look at an image inside a terminal. Thankfully, there is a better way for that. And every single IPFS node, every time you start an IPFS daemon, inside your machine, you also get a gateway that you can access through a web browser. So the gateway is always available in localhost 8080, and I can type an address here to request it. So I'm going to request this folder that I just published. And you can see the list of files. Here's one good boy, and there's more here. Not only I can publish files and documents and pictures, but I can also publish a hierarchy of files. So inside here, I have a folder, and I can click on the folder, and oh, look here. Instead of listing the files, this folder had an index.html file, and I can use this to publish more than just a list of files. If I look at the contents of the folder, you will see that there is an index.html. And this file inside is linking to an image that was in the directory one level above. So even though every file is identified by its hash, when you put a file inside a folder, you can also reference files by their name. And every single path, as long as it's relative, can work. When I say as long as it's relative, I mean you cannot start with a slash. But you can start with a period or just the path of a file. So, OK, let's go to the next step. So if you're thinking like I'm thinking, when you saw that I can run index.html files and they're actually rendered, the next thing your mind is going to is Jumpstack applications. I think that Jumpstack apps are quite familiar concept for many people in this room. Those are apps that are built with, Jumpstack means JavaScript APIs and pre-rendered markups. And they're very common right now when you're building an app, for example, with React, Vue, Svelte, Angular, etc. The app is completely static. There is no server-side processing your app. And the app is usually served through some sort of object storage, like AWS S3 or Azure Blob Storage. And then it's served through a CDN before that. The app can communicate with backend resources through normal REST call or GraphQL calls or gRPC calls if you want to really be fancy. And you can do a lot. If you think of modern Jumpstack apps, well, Facebook is being rebuilt with React, and it's going to be Jumpstack. Twitter just republished their app as a Jumpstack app. You think of Gmail, Outlook.com, and a bunch of other apps. They're very, very popular. How is this relevant for us using IPFS? Well, we could obviously serve these apps through IPFS as well. So rather than having the apps stored inside object storage and a CDN, we use IPFS as a content distribution network. The APIs, as you can see, are still here. These don't have to be your APIs. Like you can, for example, interact with third-party APIs to provide value to your users, so you still do not have to manage a backend. Sorry. And this is exactly what I'm going to show you in the demo. There is a demo application you can find on GitHub if you're interested in trying it yourself, and the URL is there. So this demo app is a pretty normal application written in using the Svelte framework. You could use React, you could use anything else, and it's compiled with Webpack. This application is configured to interact with, imagine this was an enterprise application, and this is configured to interact with the Office 365 APIs, and it can show what's next on my calendar. There is absolutely no server-side processing that I manage, no API that I manage. But if I go to localhost 3000, you will see that, oops, it didn't ask me to authenticate. I forgot to sign out. Anyways, if I had signed out, it would ask me to authenticate using Azure Active Directory, and then it will get permission to access my calendar, which is stored on Office 365. This is showing the next appointment on my calendar. Tomorrow I'm going to get lunch. This place is really good here in Montreal. If you don't know that, it's great gnocchi. They're not paying me for saying this. I really love this place. And so this app is now running locally with just a normal npm run dev. So there's a Webpack server that's serving this app. The next thing we want to do is, as you would normally do, stop the server and actually run npm build to build the app and stage it. This should take just a second. And then my app will be inside the this folder. You will see here that I have the index.html and the JavaScript and CSS. I can now publish this app into IPFS exactly as I did before. So IPFS add -r and the content of the this folder. This app is published, and now everyone in the world can use this content ID, put it inside an IPFS gateway, and look at my app, the very same app served through IPFS. Again, this app does not have any backend, but I am using third-party APIs to do all the processing. So this is really cool, you're saying, but what about normal users? If I had to tell my business use, if I was an enterprise developer building an app for my company, and I had to tell everyone that in order to access the app, they have to download the IPFS application, run the daemon on their machine, which requires using a command line. There is a GUI for that, but still. Then instead of typing a URL like example.com, then I would have to type the URL of gateway and that very long string, which is the address. So thankfully, there is a solution for that. The first thing is that your users don't necessarily need to run IPFS on their machine, and they can use a third-party gateway. There are a few public gateways. Here you see two examples, gateway.ipfs.io, which is the quote-unquote official one, and a third-party one served by Cloudflare at cloudflare-ipfs.com. And I am highlighting Cloudflare in particular, and we'll see that in a moment why. So by using this, rather than going to localhost 8080, you can go directly to these addresses, and you don't need to run a daemon locally. The next thing is the URL is pretty complicated. Like imagine telling someone over the phone that they have to go to cloudflare-ipfs.com/ipfs/qmy, etc., etc. This is absolutely not nice. There is a solution, however, and that relies on the IPNS or the Inter-Planetary Name Service and on DNS link. So we can create a TXT record on a domain, and that TXT record can contain the address of a document inside IPFS. So for example, if I want my app to be available on next.italypaleale.me, I will create the TXT record on _DNS link dot the address, and that TXT record contains the content that you see here. Now that I've done that, anyone, even you right now on your laptops or phones, you can go to cloudflare-ipfs.com/IPNS, watch out for the N this time, and type the domain next.italypaleale.me, and that will load your app, the very same app. Then very last step is how we can make this even easier. So the reason why I was talking about the Cloudflare gateway specifically is because they have a really cool feature which lets you map a domain name to the Cloudflare IPFS gateway, and it lets you visit the website directly without having to type cloudflare-ipfs.com. So let's look how you can actually bring that up into production and make it so your users can use that in a very simple way. So like I was saying a moment ago, this app is now available on cloudflare-ipfs.com/ipfs/the address. But I can also change this to ipns/next.italypaleale.me, and it's the very same app. Because I mapped my domain to Cloudflare, I can actually use next.italypaleale.me. You can see here there is the TXT record with the address. And then there is another CNAME that points next.italypaleale.me to cloudflare-ipfs.com. So if I go to next.italypaleale.me, again, the very same app. The other thing that I wanted to show you is how you can actually move the next step, which is you don't normally, as I'm sure all of us know, we don't really recommend doing things on the developer machine, like running npm build, then IPFS add error, and then you have to do distribute the hash, update the DNS, etc. We can use continuous integration and continuous delivery. Excuse me. So in this Git repo, where my code is hosted, which is public, and you can take a look. This is the code of the application. I set up continuous integration using Azure Pipelines. I'm going to make a change, and for example, change the title of the page, which is coming up on my calendar, which is the only way where I'm using that. And I'm going to change it to next on my calendar. Committing the changes, and this should trigger the continuous integration immediately using Azure Pipeline. The CI will take a minute. So while the CI runs, I'm going to show you exactly what is happening inside the CI definition. The first step on the CI is to run npm install, npm install, and then run npm build. This builds the application as if it were any other application. Then we can scroll down, and this takes the application and copies the compiled files to my IPFS server using SSH. This IPFS server is something that I have running 24/7. And it is running the IPFS daemon using Docker. I'm not going to get into the detail of how you can set it up, but the instructions are in that Git repo that you saw a moment ago. So if I run docker psa, you can see, you can see that I have an IPFS node that is running Go IPFS here. This node is sudo docker is currently pinning a bunch of different files. So in the IPFS world, to pin a file means that you're always serving that file. So like I said a moment ago, every node in IPFS not only can request files, but can also seed them to other users, to other customers, or sorry, to other clients. Because of that, you might end up in a situation in which your node is seeding the entire world, or like a significant amount of data. So the IPFS daemon can periodically do garbage collection. Instead, when you add a file using IPFS add, or when you pin it using the IPFS pin command, this file is pinned to your node, and the garbage collection will never remove that. This is quite important when you have a server, and you want to make sure that your files are always served 24/7. So somewhere around here, in this long list of hashes, there is also the the app that I just built and that the CI has put to the server and pinned it. So the next step in the CI is actually the next relevant step, is that it goes and automatically uses the Cloudflare API to modify the DNS, the value of the TXT record, and to automatically point my users to the latest version of the application. For this, my domain is hosted on Cloudflare. The DNS is hosted on Cloudflare. If you have another DNS provider, you can do that as well. So the CI, let's see, should have run by now. And you can see here the CI was completed. It has built application, staged it, and updated the DNS record. And now if I refresh the page, oops, wrong page, you will see that the title changed from coming up on my calendar to next on my calendar. One other thing that I wanted to say is that I've been showing how you can use your own server, your own Linux VM, to pin the files. There are actually some third-party services that offer IPFS pinning as a service. I'm not going to name names. Those are valid options. At the moment, they do not have any SLA. So I would still prefer, personally, I still prefer having my own server, maybe in addition to using those third-party services. So now the application is live. The CI/CD has run. It has updated the code, and it's running on this domain. And everyone in the world can just access it using a web browser and nothing else, nothing more. So you don't need to do anything fancy about IPFS or anything particular. So one of the questions is, why would I want to do that? Like, what are the benefits? I've highlighted some of the benefits before. But one other important benefit that really impacted me also personally is that this can really scale. So I had one app, one static website that was deployed through IPFS and through Cloudflare. On March 13, 2019, in one day, the app somehow got viral, and the traffic spiked 5,060%. That doesn't mean 5,000 requests, but 5,060% requests compared to the previous day. My server that was seeding those files had an impact on the CPU. But if you want to see how much the impact was, it's around 1%. So again, serving 5,000 more requests, the impact was essentially zero. Part of that, sure, it's thanks to the CDN that was doing caching. But as you know, a CDN also still needs to go and grab content from an origin. And by using IPFS, I was able to really distribute the traffic really effectively. So what's next? The first thing is I would invite you to be creative and think of ways of more and more things that you can do using a Jumpstack. I showed you before, a moment ago, this demo app. This demo app had no backend whatsoever, and yet I was able to show my calendar as an example and make the app very interactive. I authenticated using Azure AD. Most organizations that are using Office 365 already are on Azure AD. The other alternative is Google Apps or G Suite. So chances are that if you're building an enterprise app, you can totally rely on authentication of one of those two. And you can use those APIs to do a lot. You can store data on OneDrive. You can use third-party APIs for generating thumbnails, for sending emails, sending text messages, or whatever you want. And I guess the next question is, could we actually get away without any backend API at all? You remember the image before, there were still APIs even if we were using IPFS. Well, I would say that not quite yet. However, we are working in the distributed web. Some people that are much, much smarter than me are looking for solutions into that. However, I promised at the beginning I would not be talking about blockchain, so I'm not going to say anything else about this. And so thank you. And you can find the sample code on GitHub. My username on Twitter and GitHub is Italy Pale Ale. It's like the beer, but rather than India, it says Italy. And I'm available for questions here for the next 5 minutes, and then you will see me also at the Microsoft booth if you have any question.